Okay guys, as I promised, I will do one of our homework problems for today. Our section is on implicit differentiation. This is when we've got our x's and our y's kind of mixed up. We don't have one simple y equals a function with x in it that's an explicit. We've got an implicit equation here. So what we have to do is we have to understand that there might be some mystery way of writing this whole thing with just y by itself, so y equals. And that's what I said is an explicit formula. So if we could do that, it might be y as a function of x like that. And what we're really looking for is what is the derivative of that function y. So that would really be, if we use this kind of notation, it's not totally orthodox, but it's kind of useful to understand it like that. If we wrote the derivative of y as some sort of derivative here of our function of y in terms of x, f of x, we can see how it will help us sort of think about breaking this apart and doing this one step at a time through implicit differentiation techniques. So what I do is I say, well, okay, I'm going to differentiate each of these things in terms of x. All right, well, there's no x here, but we know that we can understand it as a function of x. So our chain rule says that really if I had f of x to the fifth, what I would do is I would take the derivative of this, bringing the 5 out, kicking it down a notch to 4, but then I would take the derivative of that. Well, the derivative of that, we're just going to write it as y prime. So what I'm going to do then is I'm going to say, well, this is going to be 5y to the fourth then times y prime. That is the chain rule put into action there. Sometimes it's hard to recognize when we do that. Well, we do it in this case because we're thinking of y as being a function of x right there, okay? We don't do that when we got x because there it is, it's x, we can differentiate that. It's not a function of itself. So this, though, is the product rule, okay? So how do I differentiate this? Well, it's this times that, so I do plus, from there comes down, I do this times the derivative of that. So x squared times the derivative of this, very similar to this. Maybe you want to pause the camera and ask yourself, how did I do this? Well, I'm just doing it with y to the third, and then I'm going to write that right there. And then I'm going to do this times the derivative of that. That part here, this is going to be our product rule. So it'll be then plus y to the third times the derivative of this. Well, that's just 2x, so I can do that. Okay? Then that's going to be equal to, we'll get to this later, but what is this part? If you need to pause the camera, you can do it. But it becomes 3y squared times y prime. That's our differentiation. Just like this became 5y to the fourth times y prime, this becomes 3y squared times y prime. Plus, and then this part. Okay, well now differentiate this. All right? Again, pause the camera if you want. Try to do it. Differentiating this with regard to x becomes 0 plus, how do I do this? Well, that's going to be the chain rule and the chain rule and the product rule. Here, these are being multiplied. So again, I'm going to do this times the derivative of that plus that times the derivative of this. So this times the derivative of that is y times. Okay, how do I differentiate this? I keep it e to the x squared, because when we take the derivative of e, it stays what it is, but then the chain rule tells us I have to differentiate inside there, so that's times 2x. Okay, now plus, I'm losing room here, I think I'll erase that, this times the derivative of that, so that becomes e to the x squared times y prime. The derivative of this is just y prime. Alright, that's my whole equation when I've differentiated it, but I need to then, our goal is to find out what is this y prime in terms of these parts. So I need to factor out, there's a y prime, there's a y prime, and there's a y prime. So you identify where your y primes are and you get them all to one side of the equation. So this whole unit I'm going to write again, 5y to the fourth, and there's my, actually, you know what, I'm going to not write the y prime, I'm going to factor it out. There's y prime. So 5y to the fourth, taking that out. Here it is again, so it's plus x squared and y squared, and I'm going to put the 3 out front. Okay, I'm just trying to clean it up. But there's no y prime here, so I'm going to write that outside. Y to the third times 2x is 2xy third. This part here has got a y prime, so I'm going to subtract it, and then I'm going to factor out the y prime. So when I subtract this, I bring it out here, it's minus e to the x squared, and the y prime I factored out. So if I brought that y prime back in, it would be there. There's my equal sign. Whoops. Nope, that's a plus sign. And then there's my equal sign. I've taken this and I've moved it. All I've got is this part, 2xy times e to the x squared. Okay, so there's a lot of tidying up that you have to do. Now, I'm going to move this over to this side. I'm going to write it one more time. Y prime times 5y to the fourth plus 3x squared, y squared minus e to the x squared, close parentheses, equals then, if I'm subtracting this, I'll write this out front, 2xy e to the x squared minus then 2xy to the third. All right? I just want to get this by itself, so if I divide both sides by this denominator, then these will cancel, and I've got the y. So this basically is going to be my answer here. 5y to the fourth plus 3x squared y squared minus e to the x squared. That's the answer. However, the book will tidy it up even more, because you notice there's a 2xy and a 2xy. I can factor that out. I think I'm going to do it by working in reverse up above. This would become then 2xy, and inside is e to the x squared minus, when I take out a y, that goes down, so it becomes just y squared. So that's the numerator, and that's the denominator, all right? And that will be your complicated but yet correct derivative of this implicit function derived in terms of x, all right? So I think this is the most complicated one. You can compare your work to the odd numbers, 5 and 7 and 3, I guess, and see how it goes. Good luck.